Refer to the soil profile shown in the figure. First, calculate the variation of sigma, u, and sigma prime with depth. Second, if the water table rises to the top of the ground surface, what is the change in the effective stress at the bottom of the clay layer? Thirdly, how many meters must the groundwater table rise to decrease the effective stress by 15 kilonewtons per square meters at the bottom of the clay layer? The first thing that we will do is to calculate the dry unit weight of sand using the equation specific gravity of the sand multiplied by the unit weight of water all over 1 plus the void ratio. Substituting all the given values, we have the value of the dry unit weight of sand to be 17.17 kilonewtons per cubic meters. The next thing that we will do is to calculate the total stress at depth h sub 1 using the equation sigma is equal to the dry unit weight of sand multiplied by h sub 1. Substitute 17.17 kilonewtons per cubic meters for the value of the dry unit weight of sand and 5 meters for h sub 1. We will now then get the value of sigma to be 85.85 kilonewtons per square meters. As groundwater table is on the top of the clay layer, the neutral stress at this point is 0. Therefore, sigma prime is equal to sigma, or simply sigma prime is equal to 85.85 kilonewtons per square meters considering the bottom portion of the clay layer. Next is calculating the saturated unit weight of clay using the equation quantity of the specific gravity of clay plus the void ratio multiplied by the unit weight of water all over 1 plus its void ratio. Substituting all the values, we have the value of the saturated unit weight of clay to be 18.39 kilonewtons per cubic meters. Calculating the total stress using the equation sigma is equal to the dry unit weight of sand multiplied by h sub 1 plus the saturated unit weight of clay multiplied by h sub 2. Substitute 17.17 kilonewtons per cubic meters for the dry unit weight of sand and 5 meters for h sub 1. 18.39 kilonewtons per cubic meters for the saturated unit weight of clay and 4 meters for h sub 2. Substituting all the values to our formula, we have the value of the total stress to be 159.41 kilonewtons per square meters. Next is calculating the neutral stress at the bottom of the clay using the equation U is equal to the unit weight of water multiplied by h sub 2. Substituting all the value, we have the value of the neutral stress to be 39.24 kilonewtons per square meters. Next is calculating the effective stress at the bottom of the clay layer using the equation sigma prime is equal to sigma minus u. Substituting all the values, we have the value of the effective stress to be 120.17 kilonewtons per square meters. And the variation of sigma, u, and sigma prime is shown in the table. If water level rises to the top of the ground surface, the change in effective stress at the bottom of the clay layer is given by the equation sigma prime is equal to sigma nu minus u. Here, the total stress is when the water table is at the top of the ground surface and it is called sigma nu. Calculating the saturated unit weight of the sand using the equation shown, we have the value of the saturated unit weight of sand to be 20.52 kilonewtons per cubic meters. Next, calculating the effective stress when the water table is at the top of the ground surface using the equation sigma prime is equal to sigma nu minus u. Substituting all the values, we have the value for the sigma prime to be 87.87 kilonewtons per square meters. And then, calculating the change in effective stress, we have 120.17 minus 87.87, and that is equal to 32.3 kilonewtons per square meters. Let us assume the height of rise of groundwater table to be h. The expression for change of effective stress is given by sigma prime is equal to sigma minus u, and that is our first equation. Second, calculating the expression for total stress. Sigma is equal to the quantity of 5 minus h multiplied by the dry unit weight of sand plus h multiplied by the saturated unit weight of sand plus h sub 2 multiplied by the saturated unit weight of clay, and that will lead us to our second equation, which is sigma is equal to the quantity of 5 minus h multiplied by 17.17 plus 20.52h plus 73.56. Thirdly is the expression for the neutral stress, and that is equal to U is equal to 4m plus h multiplied by the unit weight of water, or U is equal to the quantity of 4 plus h multiplied by 9.81. Calculating the rise of groundwater table from the equation 1 and substituting the equations 2 and 3 in the equation 1, we have the value of h to be 2.32 meters, and that is the value of the rise of the groundwater table.